Hello, good morning. Thank you for toiling through the rain to get here. So today we're carrying on with Dretske on representation. In 2 days' time, on Wednesday. What day is today? 2 days. Wednesday. On Wednesday, thank you. I'm sorry, yes, it's early in the week. On Wednesday, we'll go on to Fodor's paper in the Reader. Fodor's paper is a little bit unusual among the papers in the Reader. Most of the papers in the Reader are really the simplest, clearest explanations of the view you could have. Fodor's, they may strike you as complex the first time you read them, but once you get the idea, when you go back and read them again, you see it, I hope, it really couldn't have been put much more clearly. Fodor's paper is a little bit unusual. It's a very important idea in that paper, but it's put with great complexity and, well, I don't know, it's your call as to what you do. I just warn you, it's the one exception to it's a standout among the papers in the Reader. Okay, so the general question we're looking at is, what's the source of the existence of standards of truth and falsity for representations? How does it come about that in the world as described by physics, such a thing can be happening at all, that you have standards of truth and falsity? And all the argument of the first few weeks has been that it's something to do with causal connections between the representational system and the world. But the puzzling thing about that is lots of things stand in causal connections to other aspects of the world without being representational. So it can't be just causation of itself that is generating the existence of standards of truth and falsity. Something else must be going on. The mere existence of causal connections can't constitute the existence of standards of right and wrong. And it's just that problem that when Dretske talks about function, he seems to be intending to address. So there are two key notions in Dretske's theory: the idea of X indicating Y, and the idea of it being the function of something to indicate Y. So just to indicates is where all the causal stuff goes. Indicates is where we pack in all the kind of causal chains. The general definition is something like R indicates C if means something like if there's an R then C. And maybe typically that will be because C's cause R's. So if you say smoke indicates fire, that means if there's smoke then there's fire. And typically that'll be because fire causes smoke. Yes? And that's obviously quite a general idea. Notice, incidentally, that if you just stick with this notion of indication, you don't have anything that lets you make sense of informative identities. What I mean is, if C and D are the same thing, and if R indicates C, then R indicates D. So if you've got something that indicates the presence of water, and water is H2O, then that thing indicates the presence of H2O. If you've got something that indicates the presence of Hesperus, and Hesperus is phosphorus, then that thing indicates the presence of phosphorus. You see what I mean? And I mean, really, in the background here is the point is it's like that with causation, that if X causes Y, and X is identical to Z, then Z causes Y. Is that plain enough, or should I give more examples? So there's something about meaning that is missing here from this talk about indication, because we want something that is more fine-grained than this. Yeah? And this is where one thing that the notion of function, place where the notion of function comes in. The notion of function does quite a lot of different things in Dretske's picture. One thing it does is it lets you separate the case where C might be identical to D, but the function of a meter might be to indicate C rather than to indicate D. Yeah, you've got something that indicates the presence of water. You know, the designer of the thing might have had no idea that water is H2O. So it's not the function of the thing to indicate the presence of H2O, even though water is H2O. Again, stop me if that's too fast or abstract. Is that okay? Function, yep. The problem is that if we're giving an account of representation, we want to know what the difference is between representing something as, let's say, water and representing it as H2O. Yeah, they should be different things. Yes? But if you just say, if your only notion of representation was indication, then you couldn't make that distinction. Because if something's indicating the presence of water, then it's indicating the presence of H2O. That's a problem, right? Is that a problem? Put your hand up if you think that's a problem. Very good. Okay, thank you. Put your hand up if you'd like me to go over that one more time. I see. Right. Okay. That's the definition of indicates there, right? So we want to be able to say, let's say the sign water. We want to be able to say the sign water has a particular kind of meaning, particular kind of representational status. Yes? Okay. So I suppose I'm good at whether there's water there. And whenever I see water, I cry, water! Right? So now you can tell whether there's water there by just listening to my reactions. Yes? If I say water, that will indicate the presence of water. Yes? Okay? Are you all with me so far? Yes? I know it's early. Okay. Okay. So if I say water, that's going to indicate indicates water. Okay. So you could say, well, that's what the meaning of the word water is. It indicates the presence of water. Presence of water, I mean. Yes? Okay. But if I am a good indicator of the presence of water, am I also a good indicator of the presence of H2O? Yes, I can but be, because whenever there's water, there's H2O. Yeah? So if I say water, that's also a good indicator of the presence of H2O. But we want to separate these things and say water has a tie to, the word water has a tie to this stuff thought of as water and not to this stuff thought of as H2O. You see what I mean? Water and H2O are water is representing the substance in one way, H2O is representing the substance in another way. Was that too fast? Water and H2O mean different things. Yes? But so far we haven't captured any difference between them. Because the word water is indicating water and H2O. Yes? Yes, that's right. H2O indicates water. Yeah. So if I cry H2O, that will indicate the presence of water, and that will indicate the presence of H2O. So yeah, that fills out the picture, right? So I've got no difference in what water indicates and what H2O indicates. Sorry? Then they have the same meaning. Yeah. If our only notion of meaning is indication, then water and H2O have the same meaning. But class, do water and H2O have the same meaning? No. Thank you. Right. They do not have the same meaning. So, must there be more to meaning than the notion of indication? Yes, thank you. There must be more to meaning than the notion of indication. Okay, what supplies that little bit more? What supplies that little bit more? Yes, very good. Okay. Okay. Is that clear what the problem is and what the solution is? Okay. Okay. So, if we can appeal to the idea that, well, my intention, the function I assign to the word water is to indicate the presence of water, then I might have that intention without ever having heard of H2O. Yes? And similarly, I might be thinking about H2O, but never have thought of this stuff as water. I might be a chemist who's approached water, H2O, purely as a kind of theoretical construct. Okay, so that will get me the difference between the two. But that's talking about an assigned function, what I intend the thing to do. But Dretske's idea is you could have functions observed in the context of evolutionary theory, the role that a particular structure is serving in the life of an animal, how it fills the animal's needs. That might generate standards of rightness and wrongness too. So we do have a general notion of function for biological organs, and maybe we can apply that to the structures that we have in the brain, and that will explain how standards of right and wrong are being generated. So, two things are happening here. One is when you bring in function, you're bringing in something that's more fine-grained than the talk of indication. That's one thing. When you bring in function, you're also bringing in something normative. You're bringing in something that has to do with getting it right or getting it wrong. Because something can be well-functioning or badly functioning. You're bringing in something evaluative when you bring in function. And you're also narrowing down which indicators are relevant to representation. Because if you take any one thing can indicate lots and lots of different things. I mean, someone gave the example last time of the level of chicken feed indicating how well the chickens are, how well fed the chickens currently are. That could be a good indicator of that, but it's not its function to indicate that. So any one thing has got lots and lots of other stuff causally connected to it, and so can serve as an indicator of all our other stuff. But it's not thereby representing all our other stuff, because its function is perhaps not to represent all our other stuff. Yeah? Nothing gave it that function. Not someone's intentions, not evolution. Yep. So there's quite a lot going on when function is brought in here. But there is a general question here. If we're talking about causal connections between the representational system and the world, well, when you ask what is causally connected, if X and Y are causally connected, then X and Y must both exist. Right? It's only the way the world actually is that can be causally impacting on our representational systems. And in a way, that's really Putnam's point about the brains in the vat. It's the way the world actually is that is causally affecting your representational system. It's the way that whatever is actually going on out there, whether it's vat-tending machinery or the world the way you think it is or something else, whatever is actually happening, that's what's causally impacting on your representational system. So Putnam used this as a defense against the skeptic, but there's obviously a puzzle here, namely, if what's actually affecting you is what what's making the existence of standards of right and wrong, then how can you ever get it wrong? I mean, something imaginary, something that you were wrong about, couldn't be causally impacting on you. So there's a general question here how such a thing as error is possible. Okay, so that's, I think, where we got to, more or less, last time. Is that clear about all the different stuff that function is bringing in? Okay. So just, you remember the magnetosomes, that allow the bacterium to move towards magnetic north into deeper water. Yep. Here are two marine biologists hunting for magnetosomes in, I think, Norway. Don't say you don't learn anything in this class. And here is the magnetosome pointing towards magnetic north. So we say that thing is serving a need of the organism. Its function is to indicate the direction of the oxygen-free water, so that if it gets into, if it points towards water that is not oxygen-free, then it's made a mistake. That's the simplest case of something making a mistake, getting it wrong. And Dretske's definition was the magnetosomes pointing straight ahead means that oxygen-free water is straight ahead. The magnetosome's function is to indicate the direction of the oxygen-free water, and it does this in part by indicating that the oxygen-free water is straight ahead by itself pointing straight ahead. So putting it like that, you're appealing to the idea that the magnetosome has the function of indicating the direction of oxygen-free water. Yep. Could you just think a bit more slowly, please? No, I want to come on to that in just a second. Yeah. If you lure the bacteria into oxygenated water by holding a magnet, then I say, but you might not, then I say they misrepresented something. You fooled them. Yes? That's very intuitive. That's what I'd say. I'd say, ha ha ha, I fooled you. Another victory for the human over the animal mind. Right? Can you make your point again?
Well, I'm just wondering if you could say the magnetism made a mistake. Because if its function is to point the organism towards oxygen-free water, then it did make a mistake. But if its function is to point north, then it's doing a mistake.
Right, if its function is to point towards magnetic north.
Right.
Well, yeah, I mean, you don't mean, you mean local magnetic north. Right, we can distinguish the North Pole, the geomagnetic north, right? When I put the magnet there, it didn't point towards geomagnetic north, it pointed towards local magnetic north. Yep. You could say, when we use the bar magnet, the magnetosome correctly represents the direction of local magnetic north. So I'm slowly catching up, okay? Right. And then you might say, look, the magnetosome represented local magnetic north perfectly correctly. Yep. That's its function, to point out local magnetic north. What goes on in that case is that it represents local magnetic north perfectly correctly. It usually exploits a connection between local magnetic north and the direction of the oxygen-free water. And that thing it exploits just didn't happen to hold in this case. But at no point did it misrepresent anything. Yeah? So it's hard to say what the function is of the magnetosome. You could say its function is to represent local magnetic north. You could say actually its function is to represent geomagnetic north. Its function is to represent the direction of the North Pole. Or you could say its function is to represent to indicate the direction of local magnetic north. Of the deoxygenated water. And it's not very clear how you determine which function that is, which function it's serving. And you know what the need is? It needs oxygen-free water. It doesn't really care about local magnetic north or geomagnetic north for their own sakes. But that doesn't help us determine whether the function is one rather than the other of these. Yep. The function has become its need. Well, the systems the animal has only have functions in relation to the animal's needs. Yeah, that's perfectly clear. Yeah, we're all on board with that. To say that is just to say the functions have to be defined in relation to the animal's needs. So it's always going to be possible for us to say, look, is meeting that need of the animal by giving it information it can use to meet that need. Yeah. And local magnetic north or geomagnetic north will equally allow the animal to meet that need. Get you pointing in the right direction, because then it just uses the correlation here. Yeah. Yeah. So you see the problem here, which is this is quite general. Whenever you've got a system that is causally sensitive to something in the outside environment, you can say, well, suppose there's some distal property of the animal that the sensor is causally sensitive to. And suppose there are actually two different factors that can cause that sensor to activate. That's what you need for the case of error, right? Two different kind of factors. Then you can say, well, the animal's representing either of these. Yeah, it's just that when you get one or the other of these, you usually have this one. It's usually this one. And the animal just exploits that. Or with the oxygen-free water, the picture is you get oxygen-free water that's usually correlated with geomagnetic north. That's usually correlated with local magnetic north. And you can't tell which of these to say the animal system is functioning to indicate. And you can always set this up. There's going to be some need at the end, some need being met, something that meets your needs, your need meter down here, then something that indicates then something that's causally related to the need meter, something that's causally related to that. What do you say the function of the system is? To indicate. Yeah? So when we were talking about Evans and causal theories of reference, I said, well, if I'm talking about that cup, I'm causally responding to the cup, but I'm also causally responding to stuff like the lights in the room, the sunshine outside, the illuminant that lets me see the cup. So when you're causally referring to something, when you're referring to something in virtue of a causal connection to it, there are lots of stuff that are causally affecting you that you're not referring to. So you have problems about things like these other factors, like the sun or the ambient temperature, that are allowing you to have this causal sensitivity to these factors here. And you've got to factor them out. You've got these kind of horizontal problems in saying which thing you're representing. But you've also got these vertical problems about saying how far away in the causal chain is the thing that you're representing. And the danger is, if you let it get too proximal, then you get the result that you can never be wrong. Anytime your indicator goes into a particular state, you can say, well, here's the factor that caused it to go into that state, and that's actually what it's representing. So your indicator never gets things wrong. And this is really just pushing Putnam's point absolutely to the limit. At the limit here, it turns out you're not representing at all, because you can have representation only if there's right or wrong, but here there's no wrong. Anything you're causally sensitive to turns out to be something that you were indicating. I'm not sure if I put that very well, but yes.
So the reason that function is brought in the first place
Yeah.
is because we have this puzzled off water and we want to say that the representation is
That's one reason function comes in, yes, to get the difference between water and H2O. Yeah.
Okay. Well, in that case, wouldn't a causal theory just say they have the same?
Yeah, well, if it did have that implication, that would be the wrong answer. Yeah, that would be a real problem for a causal theory if it said they just got the same meaning. Because after all, it is an informative identity. Yeah, that's where we began. Yeah. But the function isn't coming in just because of that. The function is also coming in to explain how the standards of rightness and wrongness are being generated, how something evaluative is being generated here. And is also coming in to narrow down which causal pathways are the relevant ones. And this point is, it doesn't narrow them down enough. Yeah. Yep. Okay, I think this terminology comes from Peter Godfrey Smith. The idea is, well, if I say I'm referring to whatever's causing me to use the indicator system, yeah, then as I speak about the cup is causally impacting on me, but the illumination is also impacting on me. The temperature is not too hot and not too cold. That's causally effective in allowing me to make these references. But I'm not referring to the sun. I'm not referring to anything but the cup, even though these other factors are all influenced me. So there's some sense in which all these factors are in play simultaneously, horizontally, if you see what I mean. The sun's, the illumination and the temperature aren't further away from me or closer to me than the cup. So there's a problem of filtering out all the irrelevant causes here and saying which of the causes is the one that I'm talking about. The other dimension is when I say I'm causally affected by the cup. Well, you might say, no, it's not the cup you're causally affected by. It's a pattern of hits on your retina. You're really causally sensitive to the pattern of hits in your retina, and you use the fact that that is correlated with a cup out there. Yeah, that's what I'm really referring to, the pattern of hits in the retina. So if someone says, if I have a hallucination of a cup, so I have the pattern of hits in my retina, but I don't get the cup out there, then that's not a mistake. I was just referring to the pattern of hits in my retina. Yeah, there was such a thing there. That's the analog of this thing about geomagnetic north and local magnetic north.
Okay,
Yeah.
so the vertical problem is something having to do with the control of the whereas the
What I'm calling the vertical one has to do with the chain from the thing you're talking about to you, and asking at which point in that do you stop off. Whereas the other one is a whole bunch of things that aren't at all the one you're talking about. Yeah, I mean, they're not in that path from the one you're talking about. Yeah. Okay, so Dretsche's got a solution to this, which is to say, well, the puzzle is, what is the magnetosome representing? Is it the direction of the oxygen-free water? Is it geomagnetic north? Is it local magnetic north? I mean, I'm just curious, what do you think? Can you put your hand up if your intuition is it's representing direction of oxygen-free water? Geomagnetic north? Local magnetic north? Okay, so I would say the majority think that we fooled the magnetosome, but there's a substantial minority that say, no, the magnetosome is innocent. The magnetosome got everything right. Okay. Well, it's hard to do that. It's hard to settle that by intuition. I mean, I don't really see that you can do it by direct intuition. Dretsche's idea is, well, suppose we start out by supposing it's got two different ways of finding out the direction of oxygen-free water. So maybe it uses light as well as magnetism to indicate to find the direction of the oxygen-free water. So if it's got the magnetosome and it's got a light detector and it's got some structure S, then if we've got the light and we've got the magnetic field as both firing S, then that means that you can't identify S as having it as its function to indicate either the the geomagnetic or local magnetic north, or having as its function to pick up on the light. It must have something further out as its function. Yep. You couldn't identify it with either one. So the trouble with that is, if you're really going to be difficult about this, then you could say, well, actually all that's going on there is that S is indicating either the direction of local magnetic north or the direction of light, right? That would be the natural way to pursue the original problem. So then Dretske says, well, what we need here is associative learning. If you've got repeated exposures to X in the presence of oxygen-free water, then S will start to fire in response to X. If you've got that open-ended possibility of associative learning, you can't tie this down. You can't tie the structure down to representing any one or any finite number of these pathways, because it can always open up to another one. And that's very intuitive, because there's something about you want the representation to be something that's a reasonably sophisticated organism does, and it's kind of surprising if a bacterium with a magnetosome is already representing. The ability to learn about your environment should have something to do with your ability to represent the environment, and this is a very intuitive way in. The possibility of associative learning about some distal structure in your environment, that's what makes it representation of that factor out there. Yeah. So at any one time, you could say, all I've got here is something that responds to either this local factor or that local factor or that local factor or that local factor. But the only thing that's stable over time as the organism keeps learning is that all these pathways are coming from that one same external factor out there in the distance. So if you're capable of learning any number of new ways of detecting F-ness, then you are determinately representing F rather than anything else. So that's the solution to that's Dretske's solution to the local magnetic north problem. It's a real problem. Yep.
So, in this case, F would be the presence of oxygen.
That's right. F would be the presence of oxygen-free water. So the presence of oxygen-free water is connected to all these other factors. It's a slightly difficult example because it's not so clear you can learn about the oxygen-free water, because presumably if these bacteria get into the oxygen-free water, they just die. They don't learn anything. But if you think of it as rather being something like the direction of food, yeah, then what you would have is multiple pathways to getting you to food, and then you learn which ones, which pathways really are giving you ways of finding the direction of food associatively. And you can just learn by whether you get the food or not. It doesn't kill you if you don't get it. Yeah. Very good. Yes. 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 Yeah, that would be another way to do it. Yeah, you could say it's not the learning. Dretske, I think, is just talking about learning in the part of the individual organism, but you could talk about adaptation over time as a kind of learning. Yeah, adaptation of the species over time. Okay, I think that's about as far as Dretske gets in the article, and I think this is pretty powerful. There are a number of problems with this. One is, it's just becoming clear to me in the course of this class actually, that colour is a very difficult case for causal theories of representation. And suppose you think about how you represent things as red or blue or yellow and so on. Do you have any other way of finding out about the colour of an object than looking to see? I mean, it's all very well to say for food or oxygen-free water, there are lots and lots of different ways you can get onto that. But for colour, the only way you have of finding out about the colours of things is looking. Vision is your only way of finding out about colour. But we don't seem to be, I mean, intuitively, Dretske's problem doesn't arise there. There's no, it's not at all intuitive that we'd say our visual system is only representing what's going on at the retina or only representing what's going on in the light array. No, your visual system is representing something about the object, the colour of the object. But if that's determinate, it can't be explained in this way by the possibility of associative learning. We don't have any associative learning here. We only have our one canonical way of finding out about colour. Someone who can't do it by vision can't do it at all. Yep. One, two. Yeah.
Yeah, I would say that means that evolutionary learning is color.
Yeah, but the individual is not capable of associative learning. And the thing is, it's not whether there's learning here about colour in the first place, it's multiple pathways. Yeah. The key to Dretske's idea is multiple pathways all homing back to the same factor out there, but there aren't multiple pathways from colour to us. Yeah, yeah. Yes, right. I take it this is not in humans. Yeah. Sorry? You can hear colour? Yes. Yeah. Right, yeah. Yeah. I agree. Look, yeah. Okay. If you got, oops, sorry, I'm going the wrong here. If you got this kind of structure, yeah, with multiple associatively learned pathways to your external factor, yeah, then any one of them can be dropped. No one of them is canonical. Yeah. Now, your kind of situation is perfectly imaginable. It might be, I mean, you could have someone with very sensitive fingers who could just run the fingers over the surfaces of things and tell what colours they are. But if you dropped vision altogether, then what you'd have would be a system that didn't know anything about colour. These other ways of finding out about colour are really only guides to what you'll find when you use the canonical way of finding out about colour. You see what I mean? Namely, looking to see. And if you have that, and if you only have the canonical way of looking to see, and you don't have the ability to use these other methods, your brain hasn't been rewired, you don't actually have that capacity, you don't have these sensitive fingers, then you still are perfectly determinately representing the colour of the object out there. That's the idea, anyhow. I think it would only be a guide to the presence of the colour you could see. Yeah. Yeah. It needs a lot of discussion. This, if you think about shape, then vision and touch are equally good ways of finding out about shape. Yeah. But vision and hearing or vision and touch are never going to be equally good ways of finding out about colour. Vision is always the canonical way. Yeah. And it in its own is enough. There is another basic problem here, which is the notions of right and wrong that we have for representations, for sentences for us, they're being explained in terms of the biological functions of physical states. But when you think about it, there are lots of cases in which it might be biologically adaptive to get things wrong. I mean, I don't know if this is true, but I remember reading a report a while ago of studies of how popular people think they are, how popular other people think they are, and how happy the person is. Yeah, and when you do that, you can measure the mismatch between how popular someone thinks they are and how popular their friends think they are. You see what I mean? Some people think they're very popular and their friends don't think they're popular at all. Some people think they're not popular and their friends think they're very popular. You see what I mean? Yeah. So you can measure the mismatch here between what you think of your own popularity and what your friends think of you. And the basic finding was that happiness is correlated with there being a mismatch between what you think of your own popularity and what you think of your friends, or of what your friends think of your popularity. You see what I mean? And that makes perfect sense, right? It could be adaptive to make a mistake like that. I mean, generally, it could obviously be adaptive to be incorrigibly optimistic and think that the future is brighter than it is. As someone told me a while ago about an experiment where they had people play a computer game. And so there's a lot of stuff going on the screen, and you've got a joystick, and you can make some input into what's going on in the screen. And the experimenters set it up so you could vary how much control the subject had over what was going on in the screen. So sometimes the subject's got very little control and all that stuff just happening more or less at random. Sometimes the subject's entirely in charge of what is happening in the screen. And the subject is asked to estimate how much control they think they had in their test session. And there were two things about this. One was that everyone wildly exaggerated how much control they had. Everyone reliably overestimated how much control they had. And you can imagine that, right? You're moving the joystick, you're watching the stuff on the screen, and you're thinking, hey, I made that happen, I made that happen. There was only one group of subjects who reliably got it right about their exact level of control. Can you guess what group that might be? The depressed, that's right. The clinically depressed reliably got it right about what level of control they had over what was going on in the screen. So the general point here is that it might be adaptive not to be depressed, if you see what I mean. This was reported in a write-up called Sad But Wise. I mean, you can see how it might well be adaptive to get it wrong about how much control you have over what's going on around you. You will try harder if you think you've got a lot of control. You may do better. So there's a normativity of biological good functioning. That's normative, all right. There's something evaluative there. But it might not have much to do with the normativity of truth and falsity. Fodor makes this point like this in the thing we're going to look at next. Why should we think of the mechanisms of belief fixation, I mean, whatever causing your system S to go into its state, as always designed so as to deliver truths, rather than, e.g., repressing unpleasant facts? I mean, if there's no oxygen-free water for miles, it might still help a bacterium if its magnetosome occasionally falsely indicates the presence of oxygen-free water, right? Because then it will keep trying. Yeah, well, you see what I mean, right? And certainly something like that might be true for us. There is no guarantee that the kind of optimality that teleology reconstructs has much to do with the kind of optimality that the explication of truth requires. Yeah. So biological functions are normative notion, all right, but it's not obviously the same normative notion as truth or falsity. What's adaptive is one thing, and what's right or wrong is another. So the adaptive value of a representational system might actually just be in producing illusions. There is a final, really basic problem for this kind of approach to representation, which is the way that the notion of need is really basic to it. The notion of need is what's anchoring the whole thing, right? Because we've got indication that doesn't of itself do the work, and then we've got function, which mustn't be just what someone intends or wants. It's got to be something about what this structure is doing for the organism, what the structure is getting the organism. But if your whole system of representation is defined entirely in relation to the needs of the animal, then all you can be representing are aspects of the world that relate to your needs. And Gibson, actually, the great psychologist Gibson, seems to have thought that that's actually the right result. He talked about the affordances of an environment, and an affordance is just something about the threats and opportunities that the environment provides you with. So a coffee cup provides drinking, a computer provides typing, a chair provides sitting. Yeah. All the threats and promises in the environment, the affordances of the environment are what it offers the animal, what it provides or furnishes, either for good or ill. And there's another classic definition of affordance from Mark. It's an affordance is the functional utility of certain environmental objects or complexes taken with reference to individuals and their action capabilities. So the affordances for one species will be quite different to the affordances for another species. Oxygen-free water will afford continued life and sustenance to the bacterium. So what the bacterium is picking up on is the affordances of the world around it. Right? In general, animals are very, very practical. They only care, they only represent what matters for them, for their needs and purposes. The trouble is that with humans, human systems of representation seem to go way beyond just representing what's there for our needs and purposes. Of course we can do that. You can see there's something there that affords eating and so on. But when humans are talking about what happened in the Big Bang, or what's going on 5 miles below sea level, humans are not talking about anything that's defined in relation to their needs. That's a very narrow subset, actually, of what we do manage to think and talk about. We seem to think and talk about the way the world is objectively, the way the world is independent of our own needs. I once was visiting at a psychology department where they had a big car parking structure with, on the side of the car parking structure, it was kind of honeycombed with big cutouts, if you see what I mean. Big cutouts like this in the side of the car parking structure. And when the structure was built, people just viewed it as yet another horrible concrete thing. And what nobody had expected was that pigeons locally would find this just a wonderful spot for nesting. So they were all occupied by pigeons nesting. So there were affordances there that the pigeons could perceive. They afforded nesting for the pigeons. What humans get is not just, if we could only represent the things in our environment that were of some use to us, that offered opportunities or threats to us, we wouldn't be able to see what the pigeons saw in this. Do you see what I mean? They would see their nesting potential. We would see our car parking potential. But that would be it. And our representation should just be blind to what the pigeons see. And as we say to the pigeons, I don't see what you see in that structure. Because if we're only getting things defined in relation to our needs, and they get in relation to their needs. But that's not what goes on. If you just think about that very simple case, we can represent what's objectively going on, the shape of the thing, independent of our needs, or the pigeon's needs. We can get something more fundamental, the way the world is in itself, and then we can think about how different sets of needs might exploit that aspect of the objective world. So we seem to transcend in our system of representation anything like this kind of tie, always being back to stuff defined in terms of our needs. Okay, on with Fodor on Wednesday.